Hi everyone, Professor Bruce Olszewski here. We're going to talk about Environmental Studies 01's lecture on water pollution. So let's get into this. Okay, so there's different types of water pollution, and we'll talk about some of that. But fundamentally, the definition is any chemical, biological, or physical change in water quality that has a harmful effect on living organisms or makes water unsuitable for desired uses. So that could mean water for humans, for animals, and to be used, water that's used in agriculture. So common diseases that are associated with contaminated water include bacteria, viruses, parasites, parasitic worms, and protozoa, things like that, all these nasty things that you don't want in water. The World Health Organization, the WHO, has estimated that there's literally millions of people that die prematurely simply because of water-related diseases, and this is over 3 million people. And that many of these diseases relate to diarrhea alone, which kills over 2 million people. This is pretty substantial, and you think about how you and I could just go over to the local store and buy something and take care of our problems of diarrhea. So it's kind of crazy that people around the world are dying of this. So how do we measure water quality, and what do we look for? So they look for things like coliform bacteria, so it's water tests that are done at water treatment plants and even places that don't have water treatment plants. And then they'll look at things like the oxygen demanding waste. So you have COD, the things that absorb oxygen, take oxygen out of the water, and then that makes it toxic to many animals that live in the water and then need O2. And then there's chemical analysis that's also done to determine presence and concentration of organic and inorganic chemicals. And then they use living organisms as an indicator species to monitor pollution. So they'll actually put like a fish in some water and see if it survives, and they have a test for that, the LD50. If 50% lives, then it means one thing. If it doesn't, it means something else. So there are different ways of looking at this. They are called point sources and non-point sources of water pollution. So a point source is a specific location where the water pollution comes from. So those include places from factories and sewage treatment plants, and even things like if an oil tanker were to be leaking oil, you'd know exactly what that point of discharge is. Non-point sources are more difficult to be traced because they're not from any single source of discharge. That includes stuff like acid deposition, which we'll be discussing later in the course. This is acid rain. And sediments and inorganic fertilizers and manure and pesticides that are running off from large areas. So here's a diagram of some of this. You can see there could be some non-point sources here that just running off into a stream, and then a point source are specific like sewers that lead directly to a source like a stream. So stream water pollution problems are many because of the point and non-point sources that go directly to them. The good thing about streams is that they can recover rapidly because you have so much water moving through there, as long as there's lots of water moving through and pollutants don't overload the systems. And this has been a mechanism that's been used by millennia, for years and years and years, but we know now with increased population, increased consumption of goods, and the resultant discard of more pollutants into water, that's no longer the case. We can't rely on just more water flushing through a system, although many societies do. Other things that can threaten these streams would be a diversion of water from them, so that you have less water coming through, which then concentrates the pollutants that are in there, and agricultural runoff. And agricultural runoff includes the chemicals that are used, herbicides, pesticides, insecticides, rodenticides, and sediment. So this means dirt that runs off with poor practices. So here's some good news. Since 1970, water pollution control laws have been effective because they've greatly reduced the number and quality of wastewater treatment plants. So more of these plants mean that we clean up more water. Let me fix that right there. And what these laws have done is they've required industries to reduce or eliminate point source discharges into surface waters. An important thing about that relates to policy is that industry argued loudly that by having them internalize those external costs would make it prohibitive for them to do business. And so you still have those arguments today about why they shouldn't be responsible for things like plastic pollution and other things, air pollution, why they shouldn't be responsible. I mean, it goes on and on and on. So in 1969, there was this key event that happened. It was the Cuyahoga River in Ohio. That really is the name of this river, and it really did catch on fire. The river caught on fire because of chemicals that were in it. But that was what was needed to get Congress to act. What's kind of sad about that is that it took a river to catch on fire before Congress would act. So laws were enacted that limited the discharge of industrial waste into river systems and even into sewage systems, because they had to reduce the amount of pollutants in the first place. Industry did. And laws were also then enabled the funding of sewage treatment facilities and facility upgrades. And not that I would ever want to do this, but now there's people that can actually go fishing and swimming, and you even find wildlife in harbors in New York City. In fact, there was an article in the Mercury News in October of 2020 about pods of whales being found in the harbor outside of New York. Probably more as a result of the COVID situation, but at any rate, the water had to be clean enough to attract them. So, bad news about stream pollution is that despite progress in improving stream water quality in most of our developed countries, we're still having large fish kills and drinking water contamination due to things such as accidental and deliberate release of toxic chemicals by industries or from mines. Mines have the runoff acid mining waste that go into local streams. Sewage treatment plants that malfunction is a problem, and the non-point runoff of pesticides and nutrients. That would be things like fertilizers that are used on people's lawns and in agriculture. Numerous streams in the former Soviet Union, Russia, and Eastern European countries have suffered from severe pollution, and in India, it's a significant problem where 2/3 of their water gets polluted by industrial waste. And then there's untreated sewage problems in China as well, and in Latin America and Africa. So you can see that there's a lot of water pollution problems in the lesser developed countries. And some of this even includes large items like trash that goes into rivers and streams that then wash out into the oceans, which then contribute to the huge amount of plastic waste that we see floating around in oceans and contributing to things like the Pacific Garbage Patch, which perhaps you've heard of. But the key problem there is the lack of collecting materials like trash collection and recycling collection in these countries. The result is you have those things then contribute to water pollution. So freshwater lake pollution. So we get a lot of drinking water from freshwater lakes, and they tend to be more vulnerable to contaminants than streams simply because the water doesn't move as much. So dilution is not very effective because you don't have water moving through a lake like you do in a stream. And so, and ponds have even a bigger problem because they have smaller volumes of water and even less exchange of water. And the problem of chemicals entering lakes through dumping and runoffs in the atmosphere, like acid rains. The runoffs, again, would be agricultural runoffs, things like herbicides, pesticides, fertilizers. And then you have the problem of biological magnification that increases the concentration of chemicals into other animals. So you have through a food chain. So I'll show you a diagram of that. So this is biological magnification. So if we start here, you see here's our water, and then you have phytoplankton. That's the smallest things that are in there. And then they're eaten by the zooplankton, and then the zooplankton gets eaten by, in this example here, rainbow smelt, who are then eaten by the lake trout, and the trout is eaten by the gull, which then lays these eggs, and so these eggs will have a higher concentration of a chemical. So in this case, you can see the parts per million, the ppm, going up each time as we go from the water to phytoplankton to zooplankton to the smelt to lake trout to the herring gull to the gull eggs. Biomagnification. Cultural eutrophication is just a way to explain that the pollutants that come from humans, right? So eutrophication is a name that's given to a natural nutrient enrichment of lakes. Natural could include humans. So we have a lot of nitrates that we use in fertilizers and phosphates that we use in fertilizers. So when this stuff runs off, goes into rivers, that increases the biological oxygen demand and then reduces the amount of oxygen in the water, which then leads to large die-offs. And when things die, then you have, or as the BOD drops, you get a lot of species that will die because of a lack of oxygen and nutrients. So you'll have seen in the previous water lecture about the Salton Sea and this huge number of fish that die off there because of this very problem. Okay, so here's another diagram here that shows different point sources and discharges that come into a lake, right? So you have multiple sources here, sewage systems, industry, agricultural systems, mining, all of these things then having runoff that goes into the lake ecosystem and then changing the lake ecosystem. So the biggest lakes, for example, in the United States and Canada, that would be the Great Lakes. There's about 38 million people that live in and around the Great Lakes, and they receive, the Great Lakes receive water from 7 states, so it's a rather significant area, and these lakes get a large quantity of acids and pesticides and other toxic chemicals that are deposited from the atmosphere. In the 1960s, there was a lot of pollution that came from humans, cultural eutrophication, large fish kills, a lot of contamination from bacteria and toxic industrial waste. And then because of those problems, that led to a lot of concern, and then the concern led to actions to clean up the Great Lakes, and the key thing for cleaning up the Great Lakes was to reduce the pollution sources. So the Great Lakes, right, in case you needed to be reminded with a map. So let's talk a little bit about groundwater. We covered groundwater in the earlier water lecture, but it's important to recognize how important groundwater is. 75% of the drinking water in Europe is groundwater, about half in the U.S., about a third in Asia and Latin America. And groundwater is polluted when contaminants come in from storage lagoons of things like chemicals or agricultural waste, septic tanks that are used in many agricultural rural areas, landfills, this is where we put garbage, hazardous waste dumps, and deep injection wells that are used to get rid of some materials. And then there's also the problems of leaking, corroding tanks of gasoline, oil, solvents, and hazardous waste. And that happened actually here in Santa Clara County. It was an extraordinarily serious problem that led to studies throughout the country, which led to a boom in people consuming bottled water that still exists today. The drinking of bottled water, the underground water problems in Santa Clara County have largely been resolved. More on that later. So other things about groundwater, trying to clean it up, right? So it's a really slow process because water moves so slowly through it. So the only way to really do it is you have to pump out that groundwater and then treat it after you pump it out. And that's what was done throughout Santa Clara County, was pumping out groundwater and then treating it before it goes into streams. So major sources of groundwater contamination. Here's a graphic kind of show you some of these. Here's a waste lagoon. You can see a like mining runoff, de-icing with road salts. Not done in California, but it is done in other parts of the country where they use road salt for de-icing. Pesticides, gas stations. These have been found in our county and many others to be leaking. In fact, one of my uncles was a fire captain and had to respond to one of these where he found that there was a fire near a gas station and the fire wouldn't go out, and then they determined that the fire was caused by a leaking gasoline tank, and the gas had migrated through the soil and then had popped up in a field. And this was also an indication clearly of a leaking tank, which then also contaminated groundwater. Those types of situations made local officials become aware that the problem is that when you put a steel tank underground, the thing's going to rust and it's going to leak, and then the leaking fuel will then go into groundwater, and that is exactly what happened in the South Santa Clara County area that leaked trichloroethane and chlorethylene into groundwater. Again, more on that a little bit later. Then landfills are also a key problem. Today, we poke holes all around the landfill to test groundwater to see if it's contaminated with anything that might come from the landfill. And also today, we have household hazardous waste programs to collect hazardous waste so that it doesn't go into mixes with garbage and go into landfills, which could then leak and get into groundwater. And you'll see some others here. For example, septic tanks. So what happened in South Santa Clara County was a leak at the Fairchild semiconductor plant. The city and their urban planning people wanted to move some of the high-tech industry to the southern part of San Jose so they could basically create some industry for themselves there and also reduce commutes by having Silicon Valley not located just up in Mountain View and Sunnyvale and Santa Clara and North San Jose, but to have some located in South San Jose. And so Fairchild went out and located there, and in 1981 there was a woman who suspected a leak because there was her family and other families had children that had been born with cleft palates. That means that if you put your tongue at the top of your mouth and top of your mouth isn't there, you have a cleft palate. And the cause of that was thought to have been the chemicals that they were drinking. So she wasn't sure that there was chemicals at the time, but then there was a test done of a well that was near Fairchild, just a few hundred feet away from Fairchild, and it was found to have high levels of TCA, TCE, PCE, and some other and xylene. So different chemicals that were used in those days to clean circuit boards. So multiple wells were found to have been exposed. All of them were closed, and today they are still monitored. And so soil was removed. Fairchild closed the site and is no longer existent. In fact, if you go out there today, you'll see a Safeway on that site. It's on the corner of, trying to remember the name of the street out there, Monterey Highway, and it's near the Santa Teresa Golf Course. Burnell, that's where it is. Burnell Road. Okay, so and then after that was done, they started testing other sites around the county to figuring out if this leak was happening at Fairchild. It was probably happening at other sites. So they did find another major contaminated source at the IBM research facility in South County, and then 179 other sites. The result of this was the Scher Bill, which was named after the author Byron Scher, which required double containment of any container that went underground. And so what happened around those time, and I don't know if you can recall this when you were a kid. I know I saw a lot of it. All gas stations were being dug up, and all of the gasoline tanks were being replaced with double containment, along with a number of indicators that would show if there was any leakage from the double containers, the double contained tanks. So, 179 sites in Santa Clara County. Here's a map of them all here. They're all tested now. They're not. They were removed from providing sources of drinking water. If you're concerned about your drinking water, you can contact the Santa Clara Valley Water District. They will tell you exactly where your water comes from, and exactly what was found in it. More on that in just a bit. Some other things about groundwater contamination in the San Martin, Morgan Hill area. There was a facility out there that was making road flares. There was another one that was actually testing rockets as well, and that was found that perchlorate from these sources were found in drinking water, and it was causing problems with young people, generally people under the age of 5, I think it was. And there were about 800 wells in that area that provided water for irrigation and human consumption and agriculture, and most of they've been sampled since then, and there are no longer being used to provide water for consumption. But the result was that the company that had been involved, Olin, O-L-I-N, ended up providing bottled water to residents while this situation was getting sorted out. Here's more detail about where this was located in South County. You can see here Monterey Highway and US 101. And you can read more about this if you'd like. So, in the United States, about a quarter of our groundwater has some sort of contamination. In the U.S. alone, many pesticides are found in groundwater. Industrial waste ponds typically do not have liners, which means that the chemicals that are put into these then leak into the ground. Underground storage tanks are leaking, and then you have people that are then exposed to these things. So action had been taken around the country after it was discovered, after the problem was discovered here in Santa Clara County. But that doesn't mean that that's the case in other countries. People in China, there's tens of millions of China and India that are still drinking contaminated groundwater. And in coastal areas, you saw in the earlier or previous lecture that when you pump out groundwater, you bring in salt water, you have saltwater intrusion. So you have salt water mixed with fresh, so now that contaminates that water. So it's important not to overdraft as well. And that's really important that in other countries that does not happen, because 40% of the world's population lives within 100 kilometers of the coast, and 14 of the world's 15 largest metropolitan areas are on or near the coast, like New York City, San Francisco, Seattle, for example, Los Angeles even. And one of the problems as well is that some U.S. coastal waters have found have large colonies of viruses from raw sewage that have been entering the the oceans which they're nearby. For example, there was recently a story on 60 Minutes, the TV show that is on every Sunday night from CBS, and pointing out this raw sewage that comes from Mexico and then moves up and gets into San Diego area and causes this huge problems there. Okay, so this is just an example of the pollutants then that would be near a coastal city. You can take your time and look at this. I'm going to move on. The other problem has been that about dumping. So in the United States, coastal dumping of garbage doesn't happen anymore. People still think it does, but it does not. It still happens in other countries. And that is what causes a lot of the water pollution that you see in the oceans. It's from the lesser developed countries that choose to not collect garbage and recyclables, and then it washes off with rains and floods, and then secondly is actually deliberately carrying this stuff out into the oceans. Okay, so the merchant fleet has been agreeing not to dump sewage and garbage at sea, but it's difficult to enforce an agreement when there's not a willingness to do so or being able to pay for this. Okay. So other problems of oil spills. Oil spills typically get all the news. Typical everyday runoff that carries pollution does not get the news. So I want you to make sure that you're aware of the typical everyday problem that happens, and how important that is. So there is this problem of oil pollution, and it just points out that another hazard that is related to our demand for oil products. So here's some good news and some bad news. The Clean Water Act of 1972, one of the all these laws that were happening right after Earth Day 1970, and this was one of the big ones. So the Clean Water Act had required that all U.S. rivers be fishable and swimmable. We've learned that is extraordinarily difficult to do, but nonetheless there's been this huge increase in the amount of lakes that are fishable. So that means that water cleanup or the pollution reductions have resulted in cleaner water. And so there's been huge increases there. Topsoil loss has been reduced, so we get less runoff of topsoil from agricultural areas. Sewage treatment increased, so that means when people are flushing their toilet, it goes to a sewage treatment plant, so it's treated before it then is let off into oceans or rivers. And wetlands have also decreased. Losses of wetlands have decreased by 83%, and this is great because the wetlands clean up many of these areas. In fact, there's a wetland up in the Arcata in Northern California that is also their sewage treatment plant. If you're ever up there, you can really impress your date by taking her to the wetland that's also a sewage treatment plant. Won't that make that a memorable date? Okay, so bad news since 1972 is that about 44% of lakes, 38% of rivers, and many estuaries are still unsafe for fishing and swimming. I wouldn't put a whole lot into those statistics because they change regularly, just so you know, right? And there's still a problem of livestock runoff, so animals, particularly beef cattle, pigs, chickens, there's not sewage treatment plants where these animals have been raised, and so this creates a problem of what do you do with all that sewage that comes from this, from that type of agricultural industry. So the key is testing, and so there are many individuals and that will go out and test water, so they're doing the work of government, so that's great. Could be something that you want to do when you go back to your area where you live, or perhaps you're from here. Okay, so another thing about point sources as cities develop is to move from having septic tanks to connecting homes to sewage treatment facilities like we do in Santa Clara County. It was really not that many years ago in San Francisco. All of the sewers were connected. The sanitary sewers were connected with the street sewers, which may have sounded like a good idea, except that when it rained, then the storm sewers would get filled up with water, then that water would overrun the sewage treatment plant, and then you get raw sewage that came out from the city of San Francisco at a plant near where the San Francisco Zoo is, and it would go straight into the Pacific Ocean. So that system then had to get replaced, and so now they have two separate systems. All the storm water now runs directly into the bay, and the sanitary sewer handles all the rest of it. Still, there's a problem though, because you get runoff from streets that can contain things like asbestos from brake linings, lead, paint, PCBs, and various types of litter. So at sewage treatment plants we have primary and secondary sewage treatment, and in our case in Santa Clara County and actually in the entire Bay Area we even have tertiary. That means tertiary meaning a third treatment. So primary sewage treatment is a mechanical process that uses screens, and it filters out debris like stones and sticks and branches, rags, big large debris. And secondary is a biological process where they use anaerobic bacteria to remove up to 90% of the biodegradable oxygen-demanding organic waste. And perhaps some of you have actually been able to go out and tour the facility. I think they still do that in one of the biology courses, take people out to the sewage, sewage treatment plant. That's a tour you'll never forget. Okay, so here's an example. You have this thing called a grit chamber and a settling tank. That's primary. And then secondary, which is now happening throughout the United States, you have aeration tanks, a settling tank, and then chlorine that's used to disinfect. And in tertiary, you add another level of chlorine and running it through basically coal, lots and lots of coal. And then in the case of Santa Clara, or San Jose, the San Jose Santa Clara Pollution Control Plant, they're even using now reverse osmosis to clean the water to a point where they can actually pump it back upstream, and so it can be used again as a landscape for landscaping. And there's been a lot of discussion about taking that water and then pumping it or allowing it to settle into percolation ponds where it could then go into the groundwater. Controversial. I'm not so sure I trust it, mostly because systems break down, people don't keep accurate records, and so I don't have that much faith in government that they would do it right, even though many say that that's our solution to become drought-proof. I have serious doubts, because if they're wrong, they would contaminate the entire strata that goes into groundwater and the groundwater system, which provides half of the drinking water for everyone that lives in Santa Clara County. So for myself, I'm opposed to it, to putting tertiary treated water into groundwater. So this shows you kind of how this works. It's a little bit different from area to area, but essentially that's how it works. Of course, even after you do this, you have to figure out what do you do with the sewage sludge and the wastewater. So in our county, wastewater, after it's treated, goes directly into the San Francisco Bay. So cleaning it up has been essential to make the water cleaner in the San Francisco Bay. Yet you'll still see signs around the bay that says don't eat the fish in the bay, or greatly limit yourself, and it's mostly because of mercury poisoning, mercury that came from mining in the hills of South San Jose, about in the 1920s, 30s, I think it was. Before the war, when they needed to get that material. So then what do you do with this tertiary treated water? Much of it could be used to irrigate landscaping, which is probably not a risk because it's at a higher level in the ground. Using it for flushing toilets, which is what they do, and I believe we're doing it at San Jose State, taking that tertiary treated water and on campus. I'm pretty sure we're using it for agriculture. I'm sorry, for the fields at the football field as well. And if you're in an urban area and you're near a forest, you could use that water to irrigate the forest. So drinking water quality, right? According to the World Health Organization, about a fifth of the people on the planet, about 20%, don't have access to clean drinking water. Many are in China. That's changing as China has developed its economy with massive infusion of money from global trade. Russia has a significant problem with drinking water, as does Africa and in other poor areas. And so urban slums in developed countries have this problem of poor quality drinking water, and then it requires people to actually purchase drinking water from another source. You have to figure out if you can believe those sources where you might buy your drinking water. And I might explain why immigrants coming into the U.S. buy a lot of bottled water, because they know from where they came that you can't trust it. Now in the U.S., drinking water is generally, well, it's tested, and I can tell you that I drink it at my house. I'm not worried about it because I'm aware of the testing that happens by the Santa Clara Valley Water District, and that you can read these tests, and they're available to you online. You go to their website, or valleywater.org, I think it is. Okay, so United Nations has an estimate about clean water cost. And again, these numbers would be, I'm sure they're different now, but by providing clean water, you have fewer illnesses, you have fewer deaths that are related to that, and you have healthier families. So in 1974, the U.S. EPA, the Environmental Protection Agency, established national drinking water standards, otherwise known as the maximum contaminant levels. Now, this does not include privately owned wells, because it covers wells that are and drinking water sources that are provided by government. And so some of the owners of private sources are reluctant to support mandatory testing, but probably 99.9% of us get water from a municipal source, and we're we're not pumping it out ourselves. If you are, get it tested. So should we drink bottled water, right? Because that's what a lot of people do because they don't believe that the water's safe. And so why do we do that? Because there's a fear of getting sick from tap water. And so that's why many people buy bottled water. And some of them will install purification systems. Some are expensive, some not so. But then the problem with water purification systems in your home, such as the Pure water filter, is that if you don't replace the filters, you actually concentrate the pollutants in the filter mechanism, which is basically ground up charcoal or carbon, coal, essentially is what it is. So it's essential that if you rely on these things, that you replace the filters on a regular basis. Otherwise, it makes the water worse over time. The other problem is that many bottled water brands actually have bacteria in it, and they all have some sort of microplastics in them. And so you end up ingesting the plastics that are in the bottled water. And not to mention, then you've got the problem of what do you do with the plastic bottles. So when you buy bottled water, you pay for the bottle. Oftentimes you don't bring them back for recycling. People don't, and then they end up in the waste stream. So it contributes to a larger waste problem, not just in the U.S. but around the world. The International Bottled Water Association does have voluntary standards for testing, but cities have to meet, or water districts have to meet even higher standards. The Santa Clara Valley Water District, who now calls themselves Valley Water these days, they've done some reports comparing bottled water with tap water, and I encourage you to look at that yourself and find out yourself. But I can tell you, for me, I'll take tap water. Do I drink bottled water? I do when I go on road trips. I'll bring it with me. Okay. So solutions, pretty easy. Step 1, don't create the problem. So avoid polluting groundwater. We need to have landfills should be lined, and septic systems should be connected to storm sewer or sanitary sewers. All those other things. You get the idea. And locally, we have a thing called the Santa Clara Valley Urban Runoff Pollution Prevention Program, and I meet with these people about every month in a different capacity, but I know them, and they've hired many of my students because they go off and they do tests and they will inspect different facilities. So what SCVRP is, that's how you pronounce their acronym. It's a multi-jurisdictional cooperative effort. It's amongst the county and then the 15 cities of Santa Clara County, and then there are 13 other cities that are in the north. They're all part of this, and the intent is to reduce non-point pollution sources from stormwater runoff and other surface flows. So they look at point and non-point sources, try to reduce those pollutants. So, and they exist primarily because of a requirement from the Federal Clean Water Act and the San Francisco Basin Water Quality Control Plan. So cities have to do this because they have to reduce the volume of or the quantity of pollutants in water locally. So it's a great place for many people to get started in their environmental careers, to work as inspectors in this field. Okay, that's it for this lecture. Hope you all enjoyed it, and I'll see you in the next one.